Hello students, now we are going to study the microcontroller for power electronics. In this subject we are going to on the chapter 2nd. Let us see what's happening. This is the outcomes of this subject as already previously discussed. Now we are going on to the unit 2 directly, 8051 architecture. What are the major learning outcomes? Explain the microcontroller of 8051 block diagram. This one, first one. Second one is to describe the function of various registers of 8051 and state the function of SFRs and DPTR. Now come to the next. Block diagram of 8051 microcontroller. See the connections and various blocks. This is the CPU connected with the ROM, RAM, timer 0, timer 1, serial port, 4 IO ports, bus control, interrupt control and oscillator. Right? There is various interrupts, external interrupts and internal interrupts. External input from timer 0, timer 1, external input from serial port, TXD, RXD. TXD means transmit data, RXD means receive data. And 4 IO ports, that is the parallel ports, P0, P1, P2 and P3, all are 8-bit wide. So you can operate 8051 microcontroller with a 8-bit. So it is also called a 8-bit microcontroller. Here you see the oscillator gives a frequency or a clock pulse to the CPU. Right? In the basic 8051, first one made from the Intel, there is a 4 kilobyte of ROM available in the microcontroller on chip. There is no external memory provision. And later on development of the 8051, there are various vast variety available in the 8051 family, and there may be a external memory or a more memory or kind of provision are there. But in the basic model 8051, there is no external memory addition or more memory features are available. So you have to use only 4 kilobyte of ROM for the program storing or data storing, whatever. There is a 128 byte of RAM. See here, 128 byte of RAM for the operation of the 8051. There is a 2 timer 0 and timer 1. Both are working as a 16-bit timer or a 16-bit counter. And there is a one serial port that can transmit and receive data serially. 4 IO ports that we have already talked. There is a bus control which manages the bus data transfer, like that. Okay. This is the main operating block diagram. And you can also conclude the specifications of 8051 of the various blocks. Right? Now coming to the next. Various registers available in the 8051. The 8051 contains 34 general purpose or working register. 2 of these registers A and B hold the results of many instructions, particularly mathematical and logical operations of the CPU. Now see the register A and B mostly and compulsorily we have to use in the mathematical operations that we are going to perform in the 8051. If you are going to perform addition, multiplication, or subtraction, whatever, we have to compulsory use the register A in some places, and in division and multiplication we have to use register A and B both compulsorily. We cannot use other register, right? The other 32 register are arranged as a part of internal RAM in 4 banks B0 to B3 of 8 registers and comprise the mathematical core. Now we have to understand the 32-bit registers are arranged as a part of internal RAM of 4 banks. So there is a 4 register banks B0 to B3, and each bank contains the register namely R0, R1, R2 up to R7. Right? Now the accumulator register is the most versatile of the two CPU register, is used for many operations including addition, subtraction, integer multiplication, division and boolean built multiplications. They are logical operations, right? The register A is also used for all data transfer between the 8051 and many external memory. This is the now register is used in various kind of operation like data transfer. We can also use it. In data transfer we can also use the register, but A is one kind of register that we can use directly into the mathematical and whatever. Okay. The type B register used with the A for the multiplication and division operation, already we have talked, and has no other function other than a location where the data may be stored, right? Now see the very special function register, namely A, B, DPH, DPL. This is also commonly known as a DPTR, DPLH plus DPL. This data pointer high byte, data pointer low byte. 8 bit registers. Commonly it is known as a DPTR, data pointer register. Here we can see the addresses of those register, i.e. interrupt enable control, IP interrupt priority, port 0, port 1, port 3 and port 2 and port 3. All the ports are also working as a 4 register for the moving data from microcontroller to outside or from outside to inside the microcontroller. So here are the address of those register and PCON, power control register. There is other register like PSW. This is the most useful register in the understanding of the microcontroller. Program status word, address 0D0. Now serial control register SCON and SBUF, serial port control and serial buffer. Stack pointer. This is also one most important register to understand and program the microcontroller. Stack pointer. It indicates where the next instruction is to be located or where the next instruction will be run. T mode, T-con. This is the timer register, timer control register. T mode, this timer mode, and T-con means timer control register. Now there is a two timer register. Already we have talked in the block diagram. TL0, TH0, TL1 and TH1. Two timer registers means T0 and T1, right? Timer 0, timer 1. Timer 0 is one kind of 16-bit register, so it is also divided into two registers: timer low byte and timer high byte. Timer 0 low byte, timer 0 high byte. And same wise, the timer 1 is also divided into two parts: timer 1 low byte and timer 1 high byte. This is the addresses of those registers. Now see the operation of the stack pointer. The stack refers to an area of internal RAM that is used in conjunction with a certain outpost to store and retrieve the data quickly. Now see, when we are doing operations of some kind of interruption or emergency, then we have to store the data that is emergency to the some place. When after operation or after emergency completion, we can recall that whatever the previous data or previous addresses that we have at certain level, so we can store the temporary data and address to the stack memory, and we can recall those data and those memory. Primarily, by default, stack pointer address is 07H of the RAM. And when we are storing the data, it will incrementing and storing by the instruction of push and pop. Later on we will discuss how this will working either as incrementing or decrementing and push and pop, or how to restore the data and copy the data onto the RAM, right? Right now we are pausing up to this.